Hi there. Welcome to the first lesson of the first unit of calculus. We're kicking things off with limits. Now, limits are not really that complicated, but they're so important to everything else that we're going to learn in this class. They're like the foundation of calculus. So let's dive right in, get started, and find out what a limit is. Remember, if you want to download the notes and follow along, there's a link in the description. So to get started, we have to answer the question, what is a limit? Well, rather than tell you, I'd rather show you. So look at the first example with me here. The way you read this is the limit as x approaches 2 of f of x. And what that means, if I look at this graph here in front of me, and imagine that I'm riding along that graph until I get really close to the x value of 2. And I do that from the left, and I do that from the right. If I ride along this graph until I get really close to the x value of 2, am I converging on a certain point? Okay. If the answer is yes, then the y value of that point is the value of the limit. So in this case, the limit as x approaches 2 of this function is 1. Okay, and the way that we check for a limit graphically is we're always going to go from the left and from the right and see if those come together. Okay, for example, right here, find the limit as x approaches 0 of this function. Well, if I ride along this function until I get infinitely close to 0 from the left and infinitely close to 0 from the right, are these converging at the same point? Yes. What's the y value at that point? -2. Okay, pretty simple. Okay, but what about when they don't converge? Okay, looking here, find the limit as x approaches 1 of this function. Well, I'm going to ride along the curve until I get infinitely close to 1 from the left, ride along until I get infinitely close to 1 from the right. Okay, and did these come together? No, they didn't. So what we say, because we have different behavior from the left and from the right, is that the limit does not exist. And we're going to denote that by writing DNE, does not exist. Next up, find the limit as x approaches 1 of this function. So I'm going to ride along from the left, ride along from the right. Okay, are they converging on the same point? Yes, but there's a hole there. Okay, does the fact that there is a hole in this function change the fact that this is coming together? No, it doesn't. So the limit still exists. The value of the limit as x approaches 1 is 1. Okay? Now, what if this had been a different question? If they had said find the value of p of 1, that wouldn't exist. Okay, there's a hole there. But the limit as x approaches 1 does exist. So the function doesn't necessarily have to exist in order for the limit to exist. Okay? So that's how you find a limit using a graph. You want the behavior from the left, the behavior from the right, see if they match up. Okay? What if you're trying to find a limit using a table? Okay? For example, find the limit as x approaches 3 of x squared minus 9 over x minus 3. I can see here, looking at these x values, they're getting really close to 3 from below or from the left, and really close to 3 from above or from the right. So what's happening with the y values, the value of this function? 5.5, 5.9, 5.99. We're getting really close to 6 as we approach from the left. And from the right, 6.5, 6.1, 6.01. Again, we're really getting really close to 6 from the right. So the limit from the left is 6. The limit from the right is 6. So the limit equals 6. Even though, just like in our last example, the function's undefined at 3. That's okay. Okay. Example 6, find the limit as x approaches -2 of 1 over x plus 2. Okay. In this example, you'd have to use your calculator to fill out the table. Using my calculator, I've got, when I plug in -2.1, I get -10. When I plug in -2.01, I get -100, -1000. When I plug in -2, I divide by 0, so it's undefined. When I plug in -1.999, I get 1,110. So as I approach -2 from the left, it's getting more and more negative. It's tending downwards towards negative infinity. And as I approach -2 from the right, it's getting bigger and bigger and bigger and bigger. It's tending towards infinity. Okay? Are infinity and negative infinity the same thing? No, they're not. So this limit does not exist. Example 7. Using a graphing calculator, determine the limit as x approaches 0 of sine of 1 over x. So the first thing we're going to want to do is draw this graph so we can see what it looks like. It's kind of a weird graph because right around the origin, it bounces up and down really, really, really fast. Okay, and if you try and use your calculator and zoom in, like maybe you want to zoom in on the origin and try and see where it crosses, on my calculator, when you do that, you actually just get a solid block of color. And the reason why it does that is because as x gets closer and closer to 0, this function bounces up and down an infinite number of times. So we can't see, as you get closer to the x-axis, where it's crossing at. So this is actually a special type of problem. We say this limit does not exist due to oscillation, because it's bouncing back and forth an infinite number of times. Okay, so that's an important one to tuck away and remember for later. The limit as x approaches 0 of sine of 1 over x does not exist due to oscillation. And lastly, what I've got here is a released AP problem. What I did was I actually took the 2008 and 2012 AB and BC tests. I took all the multiple choice questions and sorted them into my notes. So every time there's an AP question that goes with the notes, it'll be at the end. So 2012 AB number 5 says, the graph of a function f is shown above. Which of the following statements is false? A, the limit as x approaches 2 of f of x exists. Well, let's go to 2, right along the curve from the left, right along the curve from the right. Are we approaching the same point? Yes, we are. There's a hole there. Does that matter? No, it doesn't. The limit exists. B, the limit as x approaches 3 of f of x exists. Well, let's go to 3, right along from the left, right along from the right. Are we approaching the same point? Yes, we are. The limit exists. C, the limit as x approaches 4 of f of x exists. Well, let's go to 4, right along from the left, right along from the right. Are we approaching the same value? No, we're not. So the limit as x approaches 4 of this function does not exist, so this statement is false. Okay, so quick recap. When you're trying to find a limit using a graph or a table, you want to look and see, does the behavior from the left and the behavior from the right match up? If so, the limit exists. If not, the limit doesn't exist. Hope that helps. Thanks for watching.